Assalamu alaikum. Today we are discussing theories of catalysis. It is a topic of surface chemistry and for semester 6. There are two theories to explain the process of catalysis. The first one is known as intermediate compound formation theory, and the second one is known as adsorption theory of catalysis. There are two theories of catalysis. The first one is called intermediate compound formation theory, and the second is known as adsorption theory. First, we discuss the intermediate compound formation theory. This theory was proposed by Clement and Desormes. Clement and Desormes in 1806. According to this theory, if we have a reaction in which two reactants A and B are reacting in the presence of catalyst C to give the products, then this theory suggests that first one of the reactants reacts with the catalyst C and produces an intermediate compound. First step is that the reactant A reacts with the catalyst C and produces an intermediate compound denoted by AC. It is intermediate compound. This intermediate compound is highly unstable or more reactive. As it is highly unstable or more reactive, that is why it reacts with the second reactant B. In the second step, the intermediate compound AC, which is unstable and highly reactive, it reacts with the second reactant B and gives the product AB, and the catalyst is set free. To repeat the cycle, in the first step, reactant A reacts with the catalyst and produces AC, which is an intermediate compound. This compound is highly unstable and more reactive. That is why as soon as it is formed, it reacts with the second reactant B and gives us the product AB, and the catalyst is set free to repeat the cycle again and again. Intermediate compound formation theory was originally proposed to explain the homogeneous catalysis, and the examples are, the first example is the formation of manufacture of sulfuric acid by lead chamber process. The main reaction in this process is the reversible oxidation of sulfur dioxide with oxygen to sulfur trioxide gas in the presence of nitric oxide gas as catalyst. Now, in the first step, nitric oxide, the nitric oxygen, which is the first reactant A, it combines with nitric oxide to produce NO2, nitrogen dioxide. Now, it may be considered as intermediate compound. Now, oxygen is reactant A, NO is catalyst, and here we have AC. It is the intermediate compound. In the second step, NO2, which is intermediate compound AC, it reacts with the second reactant SO2 gas and produces a sulfur trioxide. It is sulfur dioxide may be considered reactant B. Here we have the product AB, and the catalyst is set free. The catalyst, nitric oxide, the first reactant A, which is oxygen, it reacts with nitric oxide, which is catalyst, to produce intermediate compound nitrogen dioxide or peroxide, which may be represented by AC. In the second step, the compound, intermediate compound AcrNO2, it reacts with sulfur dioxide and produces SO3. Sulfur dioxide may be considered reactant B, SO3 is the product AB, and NO is set free. The second example of theory of intermediate compound formation is the formation of diethyl ether from ethyl alcohol used in excess in the presence of concentrated sulfuric acid. As catalyst. In this case also, the reaction is C2H5OH, C2H5OH in the presence of concentrated sulfuric acid, we get C2H5O, C2H5 diethyl ether plus water. It is the product. It is actually intermolecular dehydration of ethyl alcohol. Now, according to theory of intermediate compound formation, the first molecule of ethyl alcohol reacts with sulfuric acid and produces ethyl hydrogen sulfate C2H5HSO4 plus H2O. It is ethyl hydrogen sulfate which act as intermediate compound. Now this intermediate compound, ethyl hydrogen sulfate C2H5HSO4, it then reacts with another molecule of ethyl alcohol which is used in excess. It is second molecule is acting as reactant B. Now H2SO4 is regenerated, the catalyst is regenerated and diethyl ether is formed. It is the product formed and the catalyst is regenerated to be used for the second step or to be recycled. Now in this case, in the first step, intermediate compound ethyl hydrogen sulfate is formed, and in the second step, ethyl hydrogen sulfate then reacts with another molecule of ethyl alcohol to produce diethyl ether. We can also explain the Friedel-Crafts alkylation of benzene in the presence of aluminum chloride as catalyst. Third example can be quoted as the Friedel-Crafts alkylation, Friedel-Crafts alkylation of benzene in the presence of aluminum chloride as catalyst. The reaction is C6H6, which is benzene, reactant A, plus CH3Cl, ethyl chloride, reactant B, AlCl3, aluminum chloride is catalyst, and we get C6H5Cl plus HCl. It is the product which is chlorobenzene, C6H5CH3, which is toluene. The main reaction is C6H6 plus CH3Cl, AlCl3, C6H5CH3 plus HCl. Benzene reacts with methyl chloride in the presence of aluminum chloride catalyst to produce toluene and HCl. Now, according to theory of intermediate complex formation, in the first step, the alkyl halide methyl chloride reacts with the catalyst which is aluminum chloride, and produces an intermediate compound which contains the carbocation or the carbonium ion. The first step is the formation of intermediate complex CH3Cl plus AlCl3. Now here the complex formed is CH3 positive and AlCl4 negative. It is the intermediate compound formed. In the second step, this intermediate compound reacts with benzene C6H6 plus CH3 positive and AlCl4 negative. It combines with benzene to produce C6H5CH3 to give the product toluene plus HCl plus AlCl3. The catalyst is regenerated. Here we have used the catalyst, and at the end catalyst is regenerated to repeat the cycle. So there are many reactions which proceed according to intermediate compound formation theory.